Hello dear viewers. This video is a part of a playlist about repairing the surface grinding machine 3B722 with a table travel of 350 mm by 1000 mm.
This is probably the 10th video on this channel about repairing the main linear motion pair of this machine. There is still a lot of work to be done, and many interesting technological aspects to discuss, so it is worth publishing this next video in the series. I am not a native English speaker, so I have to use a speech synthesizer. Fortunately, I studied in a school with an advanced English program, which allows me to work with text and create these videos. However, pronouncing the text correctly is difficult for me and takes too much time. This is a drawback of my videos, but I ask for your understanding. Otherwise, creating content would become much more difficult, and I wouldn't be able to prepare new videos in a reasonable time. Many of you find the content itself more interesting than the audio quality, so I prioritize quantity over sound quality. As expected, I restore the geometric shape of the guideway surface through scraping. Using precise measurements and a high-quality straight edge with minimal deviation, I remove metal only where necessary. The most challenging part of scraping is determining exactly where and how much material to remove. After several months of meticulous work, the V-shaped guideway of the main linear motion pair has been restored over its entire 3-meter length. The scraping process was controlled using an autocollimator and a precision level, as shown in previous videos on this channel. I used a high-precision autocollimator and a sensitive bubble level. Thanks to this, I can control the position of any point on the guideway surface relative to an ideal virtual plane with an accuracy of about 3 microns. Using an autocollimator with a 300 mm mirror mount, I confirmed that the V-shaped guideway, after scraping, is nearly perfectly straight. The deviation is within 5 microns, with a slight downward bend in the center. Additionally, a 1040 mm mirror mount was also used. Here is how beautifully the V-shaped guideway looks after geometry correction. Of course, the naked eye cannot detect even a millimeter of deviation at this scale, but it appears perfectly straight, and indeed, it is. So, I now consider the V-shaped guideway to be perfectly straight. What you see now is the result of about 2 months of hard work. It may be hard to believe, but the deviation does not exceed a few microns, as confirmed by autocollimator measurements. Now, I need to restore the flat guideway, which pairs with the V-shaped one. The first step in this process is determining its current geometry. Since the V-shaped guideway had wear of up to 0.5 mm before restoration, I expect a similar level of wear on the paired flat guideway. To illustrate, I will use an animation showing a simplified model of the machine being repaired. I consider the V-shaped guideway to be an ideal reference line, so I will take all measurements relative to it. Now, I need to measure the second, flat guideway. For this, I will use a high-precision bubble level mounted on a base that rests on the V-shaped guideway. The second support point of the base is on the measured flat guideway. Since the second support point, a plane with a ball, moves freely across the measured surface, independently of the level base, which is necessary due to the design of the bubble level stand, each measurement ensures the correction of the ball plane's position relative to the level base to achieve a standard, uniform mutual alignment. This system allows the support to rest on the measured plane not at a single point but in a slightly distributed manner, which is preferable in this case. Thus, measurements are taken at arbitrarily chosen points, allowing me to determine how much higher or lower each measured point on the flat guideway is relative to its corresponding point on the V-shaped guideway. Once the measurements are complete, the geometry of this guideway will be known, and I can begin scraping to achieve its flatness. At this stage, I need to determine the height of this surface at 4 points, T1, T2, T3, and T4. This video is about the methodology and tools used to accomplish this task. The distance between the support points of the stand is 300 mm. The sensitivity of the vial used is 4.5 arcseconds, which corresponds to a linear size of 22 microns per meter. However, since the support length of the stand is 300 mm, these 22 microns translate into 6.5 microns. Thus, if the bubble moves by one division on the scale, the support leg of the stand rises or lowers by 6.5 microns. It should be noted that this measurement determines the surface of the flat guideway only at its center. Additionally, its transverse tilt must also be controlled, as it will inevitably be present to some extent. I performed this check using another bubble level mounted on a much simpler stand, as shown in the video. Here is what this stand with the level actually looked like in my setup. It worked perfectly for measuring the twist of the flat guideway. The blue pieces of tape contain recorded data on point heights and surface tilt at specific moments during scraping. Using this and similar data, I performed each subsequent scraping step. Measurement data and pigment marks left by my homemade, perfectly flat 1070 mm straight edge allow me to remove metal only where necessary and with the required intensity in each specific area. Please understand that background noise is present. I conduct this work and filming in an active production facility. People are working here, performing their tasks, and they do not pay attention to us. We must accept this. Gradually, the surface is being leveled. Of course, this process is slow, as only very thin layers are removed with the scraper. There are more videos on my channel about scraping this flat guideway. As I previously demonstrated in the animation, I built a measuring device based on a precision level with a scale division of 4.5 arc-seconds, which, as mentioned earlier, equals 22 microns per meter. With a 300 mm support length between the guideways, a 1-division bubble shift on the level scale corresponds to a 6.5 micron lift of the support ball, and therefore, the flat guideway surface. Since I can clearly see 1/10 of a division on the scale, I can measure height changes with an accuracy of at least 1 micron. This precision is sufficient for this project and aligns with other tools used in this machine repair. I will call this device a stand for the bubble level with a fixed support on the prismatic guideway and a floating support on the flat guideway. Being a structurally simple device, this stand did not require much effort to build and contains no components that are difficult to obtain. I also made the bubble level myself, using a commercially available vial as its main component. Such vials can be purchased separately on AliExpress for just $14. After making the first prototype and gaining experience, I designed a second, more advanced model with improved fine adjustments. However, I have not built it yet. So, I am not using anything overly complex for this measurement, but I still perform it with high precision. This stand is assembled from accessible components. The main part is a calibrated steel cylinder, 30 mm in diameter and 250 mm long. I bought it from a supplier of machine building components. It is called a calibrated guide shaft and has the necessary geometric precision for its function in this stand. Despite its simple construction, this stand, as mentioned earlier, ensures high measurement accuracy. It may look like a handmade tool, and in fact, it is. I assembled it quickly, with minimal effort, using available materials. There was no need to make it more refined. I placed this geometrically precise cylinder on the V-shaped prism. Through a rigidly attached crossbar, the second end of the stand rests on a ball, which is firmly connected to a flat reference surface, an independent component of this measuring setup. The stand with the ball is placed on the flat guideway being measured, precisely at the point of measurement. The bubble level stand and the support surface with the ball have alignment guides to ensure their correct positioning during each measurement. These guides include a crosshair drawn on the reference glass and a front sight on the support surface with the ball. It is crucial to perform this positioning meticulously. The support plane of the level stand, which interacts with the ball's tip, is a piece of glass that is only approximately parallel to the measured surface. If the ball's contact point with the level stand is not consistent during each measurement, the measurement data will be inaccurate. The ball's contact point, as previously noted, is marked with a crosshair on the glass piece at the end of the crossbar. The center of the crosshair is the precise contact point. Thanks to this setup, I maintain an identical measuring position relative to the measured line and the V-shaped prism, ensuring accurate results. If the flat guideway at the measuring point is higher or lower relative to the V-shaped guideway, I determine this by the readings of the bubble level. Initially, I do not read the level scale directly. At the start of the repair, the scale range would be insufficient to cover the height variations due to the high sensitivity of the vial. Instead, I use feeler gauges with a step size of 0.01 mm. I place them between the support ball and the reference glass to center the bubble on the scale. By the end of the guideway repair, after leveling its surface through scraping, when height variations between measured points are reduced to about 0.03 mm, I will be able to rely solely on the bubble level readings, having calculated the scale division value for this measurement setup. At the beginning of the repair, I determine the height of the measured point relative to the V-shaped guideway by the thickness of the feeler gauge placed between the ball tip and the reference glass. This method allows me to measure the height of this guideway relative to the V-shaped prism with an accuracy close to 1 micron. Using this data, I create a height map of the flat guideway and can proceed with its restoration through scraping. The scraping process is entirely based on these measurements, which, of course, are repeated multiple times at each stage until the bubble level readings in all measurement points become identical. After completing all this work, I achieve my goal. My guideways are now perfectly straight and parallel, which brings real satisfaction. I dare to say that this is now the dream linear motion pair. I also want to emphasize that achieving micron-level accuracy in these measurements requires extreme care and precision. It requires focus, analysis of all influencing factors, of which there are many, and maximum precision in movements. Even a minor accidental impact on the instrument will disrupt measurement repeatability. If the instrument's support surfaces are not pressed tightly enough against the measured surfaces, measurement repeatability will be compromised. Microscopic dust under the support surfaces will affect measurement accuracy. Thermal expansion of instrument components will also cause inconsistencies in measurements. But once all negative influences are eliminated, and you master precise and careful movements, you will achieve the necessary measurement repeatability. Under these conditions, measurement data will be reliable, and you can confidently use them in your work. Then, you can confidently take the scraper in your hands and precisely remove any areas that exceed the ideal flatness. In this meticulous process, uncertainty is unacceptable. Acting on guesswork is not an option. The key message I want to convey, and which I demonstrate in detail, is that while ideal working conditions are desirable, they are not always necessary. Many challenges can be overcome with ingenuity and perseverance. I hope you found this video valuable and worth a like. Perhaps some viewers will find it possible to support my channel through Patreon. Since I am still developing my channel, your support is very much needed. Thank you to everyone who is already supporting me. Thank you for watching, for your likes and comments. See you in the next video. Goodbye.